Hello, hi, tenfold. My name is Mkonto, and today I'd like you to help me with this question.
Right, thank you very much for that question. It's an awesome question indeed. The important thing that you need to keep in mind here is some of the terminology that is used in these questions. Let's check it so that you guys can have an idea of what I'm talking about. It says to us here, in the figure, CD is a tangent to the circumcircle. Let's see what is going on there. We were told that there is some circumcircle that is actually happening here. In the figure, CD is a tangent to the circumcircle. Now, a circumcircle is basically the same as saying the following, guys. If you have a circle, right? If you have a circle, which we will try and draw roughly here for us to understand what is going on. If you have a circle, right, and then you have got a triangle, right? You can have a triangle that is existing inside this circle. This is called a circumcircle, a circle that encloses a triangle. We are told that that particular point C there is actually joined to D such that that becomes a tangent of the line. Clearly, off the bat, you can see that from that information, some of very interesting information is going to emerge that we can use to try and solve this question. Further, we are told that ED is parallel to CD. So ED is parallel not to CD but to BC. So ED is parallel to BC. That is the information that we have so far. Let's go and check what the question says here. The first one says to us that we need to show that triangle ABC is similar to triangle DCE. So the big triangle ABC is apparently similar to this small triangle that you're looking at here. Now, when you're proving similarity, guys, there is three things that you need to remember to find. You must find three angles in the first triangle that are equal to the three angles in the second triangle such that the order matches what you are looking at. Since A is the first letter in the first triangle, it has to be equal to angle D in the second triangle. B in the first triangle has to be equal to E in the second triangle. That is basically what we need to prove. Okay, cool. And then the last ones here, C, has to obviously also be equal to E. So now you need to find three things that are equal in those three triangles, in those two triangles, and then that will be conclusive proof that those two triangles are indeed similar to each other. So let's try and find those three things. Number one, number two, number three. You can find them in any particular order. First of all, you can see that angle E will simply be equal to angle C in the other triangle. So I'm going to say that DEC, angle DEC is equal to the second angle here that you have as a dot there, which is basically BCA. And the reason for this is because these are alternate angles, right? Since the line ED happens to be parallel to the line BC. That is the first one. Right, so I've just done the letter E and the letter C, which is the third letters of the triangles that I'm trying to prove. Now I'm going to move further on and say, if you go back to what I told you about, the angle here will simply be equal to this angle here. If I had to draw the circle, I could say this is equal to that one, applying our knowledge of the tan chord theorem, because this was apparently given to us as the tangent of that particular circumcircle. All right, so then that means that the angle we're sitting with here has to definitely be equal to the angle on B there. So I'm going to call it DCE. So DCE, angle DCE is equal to angle B in the big triangle. And this is because of the fact that it is tan chord theorem, right? Remember the following, guys. It is not really drawn on the sketch, but you might need to actually work with it along those lines. So keep that in mind, right? Once I found that the third letter is equal to the third letter, and I just did the second letter being equal to the second letter, therefore the last letters will also definitely be equal to each other. That point D there, which is letter D, that point D there, I can now say angle D is also equal to the third one, which is angle what? Which is angle A, and this is because of the sum of angles in a triangle. Sum of angles in a triangle add up to 180. So if two angles are equal, the third one will automatically be equal. Therefore, the conclusion is that triangle ABC will be similar to triangle DCE, and the reason is angle, angle, angle. Right. Moving on to the second part of this question. it says to us there, it is further given that AE equals to BC equals to 8 units. Now, it's very important for you to read information and draw or write that information on a sketch. AE, where is AE? AE is this length. It is apparently 8 units. So I'm going to write 8. It is equal to BC. BC is also equal to 8 units. Right. And then EC is equal to X. So EC is going to be equal to X. ED, there's ED. We're going to put 6 here, 6 units. And then CD was apparently given to us as what? It was apparently given to us as 5 units. Right. Now, we are required to do what? We are required to show that X squared plus 8x is equal to 48. That's basically what we need to show. Now, remember what we did from the previous questions. Once you have proven that two triangles are similar, then the sides of those triangles are going to be in equal proportions. Right. So let's see what the story is here. Remember what we proved from the previous question. We did succeed to prove that ABC, right, is similar to DCE. Right. We have proved that ABC is similar to DCE. This is basically what we proved. ABC from the previous question. These questions help you to move on. When you have found the first one, it does guide you to try and find solutions for the next question. So since ABC is similar to DCE, then we can use that to move on and try to find the relationships between the corresponding sides. So I'm simply going to build the ratios here and say to you, the line AB, right, divided by the line DC is equal to the line BC divided by the line CE, and this is also equal to that line AC, that one which we are looking at, AC divided by the line DE. That's basically the sides. These are the sides of the triangle. So the side AB divided by the side DC will be equal to the side BC divided by the side CE, and so on and so on. So when I substitute what I know from this given information, we don't know what AB is, so I'm going to return it as AB. We don't know what DC is. Do we know? Yes, we do. CD is 5. So I'm going to write 5. Do we know what BC is? Yes. Where's BC? BC is 8. So I'm putting 8 there. Divided by CE. CE is X. I'm going to put X there. And this is equals to AC. AC is the combination of AE and EC, which means it is basically 8 plus X divided by DE, which is given to us as 6. Right. Now, when you focus only on this part, and you apply your knowledge of cross multiplication, you can clearly see that X into 8 plus X will simply be equal to 8 times 6, right? Which is simply 48. And then when you simplify further, we will then get that X by 8 is simply 8X. X by X will be X squared equals to 48, which is conclusive proof that X squared plus 8x is equals to 48, which is basically what we wanted to prove.